Hey everyone, welcome back to the video 3 of the Zig series. In the video 1 we installed Zig and wrote our first program. In video 2 we covered variables, all the basic type and control flow. If you missed those, go watch them first. This builds on both. Today we are covering two topics, functions and error handling. Error handling in particular is one of the most interesting things about Zig. The way it handles errors is genuinely different from most languages, not just in syntax but in philosophy. Let's get into it. Zig functions are defined with the fn keyword. Let us type some examples together. So we move to our Visual Studio Code and we write the functions outside the main. So let's write the first simple function, like for example, greet maybe, without a return type and without any parameters. And this function will just print something. In any other languages, you can call the function like this, greet, and then you run the Zig, which is Zig run main.zig. Let it build and you see hello Zig. The second thing you want to do is create a function with some parameters and a return value. To do that, we go again to the top, we create a function called add with a parameter with a return value which is i32, we just return x plus y. And then we call this function here, let's say let result equal to 3. Okay, what does it say? Remember a semicolon. We have put the semicolon after the statement, which statement is talking about okay, so sometimes it gives you a different error. The error was that I was using let and I was not modifying the result later in the program. Remember the difference between let and const that we talked in last code. So this was a basic difference. Now you see 3 plus 5 is equal to 8. Pretty simple, right? We move back. Now we have seen. Remember just one thing. In Zig, you always have to put a return value. Without return, you cannot return, like in Rust, like the last statement without the return statement is not valid in Zig. So we have seen functions. Now let's see pop, word and calling functions. Let's look at the pub function and how the function call each other. Now, to create a public function, so the public function you already know is like something called main, and which is basically calling the result of the add. To explain what does a public function means is that this function is visible outside the current file. Main must be public because the Zig runtime needs to find it by name. The rest is basically same. Now the calling order. Notice main call but add is defined after main. In Zig this is fine. The compiler reads the whole file before checking anything. So remember in C++ that you have to define the function above the main. In Zig you don't have to do that. So if I move this function below the main as well, this would work fine because in Zig the order doesn't matter. Now we go to the main function of error handling. Before we write any error handling code, I want to explain why Zig does it the way it does. Understanding the motivation makes the syntax make sense. In C, the function fails. It typically returns -1 or null. The caller can check for that, but nothing forces them to. You can completely ignore whether a function worked and carry on. This is how huge categories of bugs happen silently. Java introduced exceptions. When something goes wrong, an exception is thrown, and it can jump across many function boundaries invisibly. Zig calls this hidden control flow and explicitly doesn't want it. Go does better. Function return both a value and an error, but the caller can still ignore the error. It is easy to forget, Zig's approach. If a function can fail, that fact must appear in its return type. Using the exclamation mark operator, the compiler forces callers to handle errors. You cannot silently ignore them. That's the rule. Take a breath here and try to read what has been written. Then we move to the next slide and called error union. So, error union. The mechanism Zig uses is called error union. Let's type this. First define an error set and the possible errors this function can return. So we go to our code base. First we create a function. Basically, let's call it divide function. Function divide is equal to I32. If y means we can also put this as float. I would put this as float. This as float as well. And basically this as float as well. Now, this is basically the thing, and you should go with 0.0, return 0.0, and then x, 1, y. So this is the basic thing, right? Now, how you are handling here is that if y is equal to 0.0, you are just printing something and returning 0.0. So now I have to explicitly handle the error in main, but I don't want to do that. So what I will do is that I will create an error union. You can do this, and actually you can do const. I just have to see where I need to define it, but maybe I need to define it here. Exactly. And instead of returning this, we return now. It says divide error has not been used, but that's fine. We are not using it anyway. And basically here exclamation mark can be a fix, but you also write something like divide error. Now this is a local variable which cannot be used outside main function. So you can do Control X, put it somewhere here, so that now it can be like, now it becomes a global variable for the code. This one can use it, and you can actually just return divide error. You don't need to return error, this thing, which is same and dot division by 0, and this is correct. Okay, so let me explain a bit. What does first thing this thing do? The return type, the exclamation mark, is the error union operator. This means that I was explaining you the exclamation mark. Okay, let me explain first this. So defines, basically this is defining a named error set. Division by 0 is one of the named errors inside it. Error names are Pascal case by convention. Okay, division by 0, basically you're creating a new error which has this name. Now, the most important thing is the return type. The return type, basically with the exclamation mark, is the error union operator. This means it will return a F64 on success, or it will return an error on failure. For beginners, you can skip defining a specific error set, and you can just write any error. Oh, I think error should be small. Yes. So any error also catches every kind of error which can occur in the code. Okay. So this is pretty simple. I hope you're able to understand this, right? Now, the try keyword. Let us call our divide function. The simplest way is with try. First, the main must change its return type to a void pointer to allow to use it. So basically, now we have to put exclamation mark, because now our main can also return an error when we call our divide function, right? And what we do is that const division result equal to try divide, and then this thing. So now we can actually run this code, and then I will basically explain what this means. Okay. To explain you this, the exclamation mark before the void means that now main can error return. Similarly, try divide, try runs divide. On success, it unwraps like the float 64 and result gets a value. On error, it immediately returns the error from the main. So basically, this is what we are doing here. Now what you can do is that just to try, you can put it to 0.0. And now if you run the same code, basically you get an error. So now it shows error division by 0, because now you go into this statement and instead of getting your return statement of this value, it returns you an error. With any error, you can catch like any error, any kind of error, and that's why basically this throws an error. Okay, so now let's revert it back to this previous state. So because we don't want error in our code, and I will put this as 2.0. Now we will go to the next line known cache. If there's a try, there will be a catch, right? So try propagate errors unwrapped. Cache lets you handle the error right where it happens and provide you a fallback instead. So what happens if you get an error, right? Currently we are not catching it. You can see your code is still throwing an error. Your code is not building. So what we do is that we put a catch here, and catch can basically have like a lambda kind of function in which basically we print something. So you will see that your code still runs later on. So what you do is that you call main.zip. Currently everything would run correctly because we are dividing by 2.0. So expected unit type found F32. Yes, that should be fine. No, this should be, oh yeah, right. You don't need to now write try basically if you're writing catch. And now it gives you an error division by 0, but it prints something. If I remove this return statement and then basically run as, so it says division by arrow catch. Okay, right. So you have to put the return statement. You cannot ignore it. So it propagates the error basically. So let's understand what it is doing. Intercept the error if one occurred. Error captures the error value so you can inspect and print it. 0.0 is basically the fallback. Here we are not basically using the fallback value. So what you need to do is that instead of returning the error, what you can do is that 0.0. And then I can delete this. Let me see if it works. Will it work? So 0.0, okay, let me return it maybe. It should return, so expect this info return type set void found a compile time float, but that is fine. Okay, the issue is that here it is void. So if I change it to F32, and in this case if an error occurs, then you know it will work. So 32 Windows zig 20. Okay, where now the issue is, okay, it cannot be anything except these. It cannot be a float value. You see, so it returns you error, but this time you see your code is compiling. So your main function is returning with the return 0. It is not breaking. So what you're seeing here is that when you do a divide, it catches the error, it prints you the error and returns 0. You can return different value from main as you prefer, but as the program said that from some values of the main are defined, so you cannot basically put everything you want. Okay, now we go to error sets. Error sets are how Zig groups and names error. Let's look at a bit more carefully. So we can create a file error, which can be something like, here we did only divide error. So now let's create a file error, which can be error, file not found, permission denied. Let's say one more error called too large. So a name file error set basically has a 3 possible value. That's what we have written, and it should be in the Pascal case. Now, if we basically use this by opening a file, so what I can do is that I can write a function here, function open file, which can take a name colon const u, it instead of void, like it can return void or it will return file error, right? And then it can say that if this you now if name sorry brackets name dot length equal to 0, you can just say file not found. It's a very simple error, right? Now we will go with a statement called differ. The last concept for today is differ. Simple idea. Differ schedules a statement to run when the current function returns, no matter how it returns. So let's create an example for you. So we say like fn do work. Keep it simple. We will keep void, and we can remove this code. This doesn't require. So let's do a print doing work. Then we can do a differ std_debug done, and then we can do try opening example.txt. Let's say. So what it is happening here? This runs when do work returns. So this will statement will return when basically do work is completed. It will not return at line number 47. So if you try to do work, first it will run this command, this statement, and then it will try to open a file. If you want to check this, what you can do is that instead of saying, well, I will repeat this, and then I will also do a std print here, doing work, returning, and we save this. And let me call do work here. So I will delete now everything which we have done here. I will keep return 0, and then basically I called do work. Returning a void. Oh, okay, I was returning error, and that's why we have to put a catch. So let it run. You see, doing work, returning, and then work completed. So the work completed, even though falls between doing work and doing work returning, it is called in the end like work completed. And that's what differ do. So the differ keyword says that I am basically delaying the execution of this part to the end when the function will return. So basically, let's do what we have learned in this exercise. Functions start with fn. Every parameter needs an explicit type. The return type comes after the parameter list, and the return is always required. Here, public makes a function public. Basically, it exists outside the file. Error handling is built into the type system. If a function can fail, its return type says so with exclamation mark, and the compiler enforces that caller to handle the errors. Either we try to propagate or cache to handle on the spot. Error sets are the compile time values. Any error except anything is fine for getting started. Now we have seen the differ runs a cleanup of the code when the function exists. In the next video, we go deep into the memory, what is stack versus heap, what is an allocator, why every zig function that needs heap memory take one as parameter. It is one of the most important concepts in the whole series. We will go through it very carefully. So this is useful. Please subscribe, please like, and let me know in the comment section how do you feel. Then I will see you in the next video. Have a nice day.